Question number 22, worksheet connected particles. A light inextensible string of length 5.28 meters has particle A and B of mass 0.25 and 0.75 kg respectively attached to its end. Okay, first things first, they're saying that the length of this string is uh, 5.28 and this length is 4 meters. So I can use this to get the length of this side of the string and this side of the string. I'll do 5.28 minus 4 and divide the answer in two parts. This gives 5.28 minus 4 divided by 2. It gives 0.64. So that means this is 0.64 meters and this is also 0.64 meters. And also notice this is 1 meters. So that means this remaining distance here would be 1 minus 0.64, which is 0.36. Okay, that is done. Now let's move on. Okay. Next, we have the weight masses as well. Let's use that to find weight. So on A, downwards, we will have a weight of 2.5 newtons. So this would be 2.5 newtons. And similarly at B, we will have a downward force of 7.5 newtons from mg, where g is 10 in mechanics. Okay. Attached to its end, another particle P with mass 0.5 kg, so that makes this 5 newtons, is attached to the midpoint of the string. Two small smooth pulleys, P1 and P2, are fixed at opposite end of a rough horizontal table. That means there's friction of length 4 meters and height 1 meters. The string passes over P1 and P2 with particle A held at rest vertically below P1, the string taut and B hanging freely below P2. Particle P is in contact with the table halfway between P1 and P2. The coefficient of friction between P and the table is 0.4. So that is the value of mu. Particle A is released and the system starts to move with constant acceleration of magnitude A. Okay, now which of these is heavier? B is heavier. So obviously this system is going to move downwards and this system is going to move upwards. Okay. The tension in part AP of the string is TA. So we'll call this force TA and this force TB. Find TA and TB in terms of A. Okay, so since particle A is moving upwards, its forward force is T, its backward force is mass times acceleration, which is 0.25 A, is equals to MA. No, sorry, forward force minus backward force is the weight, which is 2.5, is equals to mass times acceleration. This is Newton's second law. This is TA. So TA equals to 2.5 plus 0.25A. Okay, next would be the length or the tension B in terms of A. So we look at particle B. Since particle B is moving downwards, its forward force is going to be the weight, which is going to be 7.5 minus backward force is the tension, TB is equals to M times A, which gives 7.5 minus 0.75A is equals to TB. So now we have both TA and TB in terms of A as required by the question. Okay. Part 1 is done. Part 2 says, show by considering the motion of P that A is equals to 2. Okay, now P is going to move in this direction. So P will have TB here, TA here, because tension always points away from the reference point. And also, since there's friction, this is going to be mu r, and r is going to be in this direction, which is 5 Newton in this question. Okay, so for part 2, forward force is Tb minus the two backward forces Ta and mu r is equals to Ma. M is 0.5 and A is just A. Okay, now we have the expression for TB already. That is 7.5 minus 0.75A from the first part minus bracket open. TA is 2.5 plus 0.25A plus mu is 0.4 and R is 5 is equals to 0.5A. Okay, now let's see what do we get here. Solve this to get the value of A. So we have 7.5 minus 0.75A minus what is 2.5 minus 2.5 plus 0.25A and then minus what is zero point 0.4 times 5, it's 2 is equals to 0.5A. Let's move all A terms to the same side. Okay, this was supposed to be negative. Oops. And then this becomes positive, and 0.75A also becomes positive. We have 7.5 minus 2.5 minus 2, which is 3. 0.5 plus 0.25 plus 0.75. This gives 1.5A, and hence A comes out to be 2, hence shown. Okay. Okay. So we have the value of acceleration. Okay, back to the question. It says find the speed of the particles immediately before B reaches the floor. Okay, so for B, what do we know? Part 3. We know that initially it was at rest, so U is 0. We also calculated the distance here. So the distance it's covering is 0.36. We just found the acceleration of the connected particles. It is 2. So using these, we can find V. So V square equals U square plus 2AS. Zero square plus 2 times 0.36. This gives 1.2. So V comes out to be 1.2 meters per second. This is going to be the speed of V before it reaches the ground. Find the deceleration of P immediately after B reaches the ground. Okay, now as soon as B reaches the ground, the string of B will slack. So when B hits the ground, let me change the color. Okay, so as B hits the ground, P would move slightly forward. So the string will slack. And now TB is 0, not TA. Only TB is 0. So we will have to use Newton's second law again at P and make TB 0. Okay, so we're going to use this again, but now TB will be equals to 0. Okay, let's do that here. Okay, which part is this again? Part 4. Okay, so Newton's second law at P, Forward force is TB, which is now 0, minus backward force, same TA plus mu R is equals to MA. Okay, this is 0 since B part of the string, TB part of the string is slack. Okay, so this will be 0 minus TA is this 2.5 plus 0.25A plus mu R. Mu was 0.4, sorry, not 0.75, and R is 5. Okay, is equals to MA. Bring the A to the same side, so 2 minus 2.5 minus 0.25A minus this would be 2 is equals to 0.5A. This becomes 0.75A is equals to minus 4.5, which gives A equals minus 6 meters per second square.